Hello. So let's look at these examples in the lecture notes, right? It's under the binomial probability distribution. Okay, so in a new sport game, the probability that Daniel win the game is 20%, right? Daniel win the game is 20%. So means that Daniel lost the game is 80%, right? The total must be 100%. So if this is a binomial distribution, so it's either got two outcomes, one is success and one will be failure. So this is 20%, win the game in 20%. So Daniel play n games, right? It's try n times. The probability that Daniel win one time in the game is 9 times the probability that he lost in all the games. Alright? Okay. Alright. You can pause the video and try the question before you look at my solution. Okay, so in a new sport game, the probability that Daniel win the games, alright, win the game. So I just define the distribution to be a binomial distribution, alright, as there is either win or loss, right, in this game. So you try n games, there are no draw, alright. So Daniel play n games. So it's try number of try. Each try got two outcome, right? So it will be 0.2. 0.2. So 0.2 as the probability of success. And the probability that, okay, the statement here, the probability, right, the probability that Daniel win one time in the game. The probability that Daniel win one time, right? So this is a number of times Daniel win. This x is a random variable where is number of times Daniel win, alright? So means that one time he win. For Daniel is 9 times. 9 times. The probability that he lost all the game means that if he try for 7 times, let's say n is 7, he lost all the game. Means that none, no win. So no win means x equals to 0, right? Lost all the game. So win one time is 9 times of the probability Daniel lost the game. So you can understand the question again. So you try to think carefully. The probability that Daniel win one time, right? Win one time is 9 times the probability that he lost all the game, right? All the game. It means in n try, 100 times, 10 times, he lost all the game, right? So then they ask you to find the value of n, right? Find the value of n. So with this given information, they want you to find the value of n. So you know that the probability of binomial distribution formula will be defined by, let's say, x to be binomial of n try and probability of success p, and probability of the binomial distribution is defined to be, the formula will be NCR P, right, to the power of r, and Q to the power of n minus r, where the Q is 1 minus P. So we are going to using this formula to solving this problem here. So very simple. So Px equals to 1, right? Px equals to 1. So Px equals to 1 means that probability of success is 1, alright? So then it will be x equals to 1. So will be number of try, n, right? Number of try here is n. So C1, right? NC1. So Px equals to 1, so 1. So P in this case is 0.2 to the power of 1, right? R, right? P 0.2 to the power of R. So here is 1. So where else 0.8? How I know it's 0.8? So because I taking 1 minus Q is 1 minus the probability of success, which is 0.2. So 1 minus 0.2 gets 0.8. So for this you have n minus 1, right? N minus R, n minus R, right? N minus R. So it's equals to 9 times the probability that Daniel do not win. So it's NC0, 0.2 to the power of 0, 0.8 to the power of n minus 0, right? I just applying that formula, right? Applying that formula. So, okay, now it's time for me to solve the algebra problem to find the value of n. So, NC1, 0.2 to the power of 1, and this will be 0.8 to the power of n minus 1 equals to 9 times, right? NC0, any C0 will be always equals to 1, alright? Always equals to 1. So you can try to prove this, okay? NC0, or you can using calculator 5C0, 4C0, anything, you will equals to 1, alright? So then I know this is equals to 1, so it's 0.2 to the power of 0. 0.2 to the power of 0 is 1, right? This whole thing is 1. So 0.8 to the power of n, right? Okay, I further simplify, alright? Further simplify, I have NC1. So, and 0.2, 0.8 to the power of n minus 1 will be equals to 9. 0.2 to the power of 0 is 1, right? So 0.8 to the power of n. So now I'm going to further simplify again. So I can divide both sides by, okay, I can bring all this thing, go to the other side, divide 9 multiplied with 0.8 to the power of n divided by this whole thing here. So it's 0.2, 0.8 to the power of n minus 1, right? So I'm going to divide both sides by this. So later on, we write this to be 9, 0.8 to the power of n, whereas 0.2 multiplied with 0.8, right? 0.8 to the power of n minus 1, right? 0.8 power of n minus 1. You can rewrite this to be in the form of 0.8 to the power of n multiplied with 0.8 to the power of negative 1, right? As you multiply these two, you will add up, right? Add up these two, you will get n minus 1. So with this is a common factor which I can cancel off, right? I can cancel off. So then you have 9 divided by 0.2 multiplied with 0.8 to the power of negative 1. So let's evaluate this, right? Evaluate this. Okay, after evaluate this, you will getting the value of 36. Alright, 36. So means therefore, alright, I'm going to continue here. So you have know that NC1, right? NC1 is 36. Alright, NC1 is 36. By some of you may already know that NC1 is 36. You know that n will be 36. Okay, so probably you can do another, because you know that the formula for NCR, right? The formula for NCR will be n factorial divided by n minus r factorial divided by r factorial. Alright, if you keep using calculator, most of you will already forget the beauty of this formula, right? This is a formula for NCR, n factorial divided by n minus r factorial over r factorial. Okay, let's look at this, how to using this. So this will be n factorial divided by n minus 1, nr. So it will be n minus 1 factorial divided by 1 factorial, right? R factorial, 1 factorial, 1 factorial. So it's equals to 36. And n factorial is the same as 36, right? 1 factorial is 1, right? 1 factorial is 1. So it's 6n minus 1 factorial, right? So you should know how to simplify factorial. Okay, let's see. Right? Okay, we must have some knowledge for n factorial. So you know that if I have 4 factorial is, you can rewrite to be 4 times 3 times 2 times 1, right? So And I also can write as 4 times with, as you can combine these 3 to become 3 factorial, right? So same thing here, if you have n factorial, you can rewrite to be n multiplied with n minus 1, multiplied with n minus 2. As you see, keep reduce the number by 1, right? 4 become 3, 3 become 2, and minus 1, then minus 2, right? So on and so far, right? So, and I can rewrite this to be n multiplied with this, you can rewrite to be n minus 1 factorial, right? So means I'm going to write this n factorial in the form of n multiplied with n minus 1 factorial, which is equals to 36 multiplied with n minus 1 factorial, right? N minus 1 factorial. So the purpose of I writing this so that I can divide both sides by this, right? I divide both sides by this value, then I have n equals to 36. So means that it have to be have 36 try, right? 36 try means that Daniel should try, right? In a new sport game, Daniel win the game is 20%. Daniel play n times, right? So means that Daniel need to play the games for 36 times in order for Daniel to win 1 time in the game is 9 times the probability that he will lose in all games. Alright? Okay, let's look at part B. So now I have already know the value of n, right? The value of n is 36. So I can rewrite the distribution to be binomial with Daniel is actually try 36 times with probability of success 0.2, right? So, right? Okay, let's continue by the part B, right? The question asking you to calculate the mean number of times he wins, right? He wins. So as you know that this is a binomial probability distribution. So the mean, let's say you have x binomially is distributed by a binomial of n try with probability of success p. So the mean, or we said to be the expected value of x, will be you taking the n multiplied with the p, and the variance of x, right? The variance of x, the variance of this distribution will be var x, which is np multiplied with q. As simple, so if you know that the variance is var x, right? Variance of x. So the standard deviation will be the square root of variance of x, right? Now, this is all the important formula that you should know, right? That you should know. So for part B, calculate the mean number of times he wins, right? So you have 36 try, right? After we calculate, the mean number will be, I take the 36 try multiply with the probability of success here, alright? So means I take 36 multiply with 0.2, which I will have 7.2, right? The mean means that the mean number of times he win will be 7.2, right? It means that in 36 we expected that he will win 7.2 times, right? So calculate the standard deviation for the number of times he wins. The standard deviation, right? Before we calculate standard deviation, we should calculate the variance, right? The variance. So the variance will be n times with the p times with the probability of failure 0.8, right? So we were getting multiplied with 0.8, so we have 5.76, right? 5.76 as the variance. So standard deviation will be the square root of 5.76, right? Which give you 2.4, right? So this is the way you solving the problem for by the mean and variance and standard deviation for a binomial distribution. Okay, that's all for this video.